Okay, yeah, so now let's go back to our original model proposed in this paper. As we mentioned, when we previously used the simplified model, we get some results, some insights, okay? But it may be the case that some of the insights may be wrong, or I should say too restrictive, okay? We need to somehow examine whether those results, those findings are really true in a more general situation. So that's why we need general models. Okay, we're going to do that, and eventually you're going to see that for the original model, almost all the solution process are identical, and the results can directly be explained and interpreted. Okay, so we're going to do that here. So now the type theta consumer's utility function is the only thing that is different in the original model and the simplified model. Here, the type theta consumer's utility have three new parameters: delta, eta, and gamma. Okay, here, suppose we look at delta first. Delta may be delta is something positive, but it may be greater than 1 or less than 1. That means it will adjust the relative sensitivity for changes in B and changes in Q. For example, if delta is greater than 1, in that case, for example, you may imagine that delta is 2 or 3 or 4 or 5. That means people is more sensitive to changes in Q than B, or that means they care about quantity more than bandwidth. Okay, delta can adjust the relative sensitivity, and then eta and gamma can adjust how the marginal benefit of quantity or bandwidth diminish, how fast they diminish. So let me use a figure to illustrate the idea. Suppose we look at, for example, the second part here. Okay, then for different gamma, we're going to get different functions. So let's say we have different gamma. This is gamma 1 times theta. This is gamma 2 times theta. Certainly gamma 1 is less than gamma 2. In this case, as we mentioned, when gamma becomes larger, the marginal benefit diminishes slower. So that means this is just an example. The gamma 1 function may look at something like this, and the gamma 2 function would be something like this. So that means you always have the same benefit, but when your consumption becomes higher, the marginal benefit will decrease. When gamma is higher, then it will diminish in a slower rate. What does that mean? That means, for example, if gamma is large, if gamma is a very large number, that means you really prefer high quantity. You really prefer high bandwidth. Okay, gamma is adjusting the absolute sensitivity for B. Eta is adjusting the absolute sensitivity of Q, and the delta is adjusting the relative sensitivity. So anyway, even if you do not know anything what I just mentioned, at least you can understand that our simplified model is to assume that delta, eta, and gamma are all 1, right? So it's certainly a more restrictive model. Here we generalize it. We go back to the original model with all the 3 new parameters. Now we want to ask whether those results changes or still the same. Okay, so now let's somehow revise proposition 1 into this more general idea. Again, we found something that is still the same. Pricing by minutes, you will offer a single contract. If you price by bandwidth or quantity, you're going to offer a menu. Oh, before we look at something else, let's think about why this is true. We just get some constant coefficients. That's not going to affect how do we solve the problem, right? And that's why the contract format will still be identical. And then we can show that pricing by minutes is just the worst. It's not revenue maximizing. Okay. The other one, now it may depends. So pricing by bandwidth will be revenue maximizing if and only if gamma is greater than delta squared times eta. Okay, so that means whether pricing by bandwidth or pricing by quantity, which one is revenue maximizing depends on the value of the three parameters. So both of them may be profit maximizing or revenue maximizing. Okay, and now they will not give you the same expected revenue. Okay, so let's see something more. We know some insights are robust. So pricing by minutes cannot screen consumers. This is still true because there is just a single contract. Pricing by minutes is still suboptimal. Later we will discuss why this is still true under a more general a more general model. But now something becomes different. Pricing by bandwidth, pricing by quantity, they are not identical anymore. Both of them may be revenue maximizing, and the winner depends on gamma, delta, and eta. Now, let's look at whether, now we want to ask why we have this condition, why this will determine which one is optimal. Okay, we want to study what's the relationship between revenue maximization and the moral hazard. Eventually, which one is optimal depends on which one is more effective in alleviating the moral hazard problem. If we price by bandwidth, the utility function will be this one. Okay, we exclude the price. Okay, so we only focus on the utility part. If we price by bandwidth, then bandwidth will be fixed, right? And the consumer can only adjust minutes to adjust the first part. Or if we price by quantity, the utility will become this one. Quantities now become different. Quantity now become fixed, and the consumer can only adjust the second part. So now what's the key? The key is that if gamma is very large, then that means the second term is very large. And then pricing by quantity will leave the consumer a too large flexibility for a self-adjustment, right? If I only fix a relatively small portion of your utility and leave you a very large part for you to do adjustment, that means you have a higher flexibility. That means you can do better. As a consumer, you can do better. And then as a seller, I cannot do better. Right? So that's the idea. And also, so that's why pricing by quantity is not optimal. When gamma is large, this part is large, and if this part is free for you to adjust, then pricing by quantity is not optimal. Okay, when gamma is large, pricing by quantity is not optimal. Or on the other way, if delta or eta is large, then delta large, eta large, that means the first part is large, and that means pricing by bandwidth is suboptimal because this leaves the first part free for adjustment, and that's suboptimal. So it all depends on when you are looking at different pricing matrices, you really care about what's the remaining flexibility of consumers. When you offer a contract, you fix some variables, and then you care about what are those remaining parts that a consumer can adjust. What's the remaining problem for moral hazard? Okay, so that's the main issue. Also, revenue maximization and adverse selection have some relationships, right? Again, we want to analyze this condition. It depends on adverse selection. Why? Look at the functional form again. Suppose delta is small. Okay, delta is small. That means consumers are more heterogeneous in B than in Q, right? For example, if delta is 1/2, that means delta theta is somewhat a uniform distribution between 0 and 1/2. That means the distribution is more condensed, okay, it's more centered, and the consumers are less heterogeneous in quantity because delta theta is just smaller, right? So if this is true, delta is smaller than 1, then pricing by bandwidth, which screens consumers according to something related to B, will be more effective. You have two parts of hidden information, right? Hidden type delta theta and the hidden type theta. If you can choose to screen, to cancel, I shouldn't say cancel. If you are able to screen on one part, you're going to choose the one that is larger. Here, if delta is smaller than 1, then the second part, for beta, the hidden information problem is larger. So that's why you're going to decide to screen this part. When delta is greater than 1, consumers are more heterogeneous in Q than in B. Delta is 1 from 2, 3, 4, 5. Then this distribution is more random, more dispersed, and it's more effective to screen the first part. Okay, as we mentioned in the footnote, ADA and tau also have some impacts. It's not so easy to do a apparent or transparent interpretation, so we do not discuss it here. But as you may expect, if ADA and tau are just 1, then the condition will really reduce to the condition here will really reduce to delta is greater than 1 or less than 1, exactly what we discussed here. Okay, when eta and gamma are something else, together they form this condition. So here we have adverse selection problems. We have two adverse selection problems, even though they are somewhat correlated, but when you can tackle one of them, intuitively, you tackle the one that is more serious. Okay, now let's use what we have done for theory to explain current practices. So we know few data services nowadays are priced by minutes, right? Certainly there may be some reasons, okay, at the supply side. But as the consumer side, we know why this is true. Why people do not price 3G or ADSL by minutes, because it is just not revenue maximizing. When we exclude all those cost terms, all those supply side constraints, it's just not revenue maximizing. That's why we should not use it. ADSL is typically priced by bandwidth, at least for these days, right? Why this is true? ADSL consumers are more heterogeneous in applications they prefer, and that means bandwidth, right? All different people use ADSL at home. For me, I only use low-speed applications like email, like Facebook, like PTT. But for for other users, they may need to play video games or online games. They need to use high-speed applications. So people are heterogeneous in bandwidth. So pricing by bandwidth is more effective because people are just more heterogeneous there. On the other hand, 3G, 4G is typically priced by quantity. Why? Because nowadays, very few consumers are using speed demanding applications on 3G or 4G network. Most of the time, when you use your cell phone, when you use your smartphone, you are doing text messaging, Line, or Facebook or whatever. You do not typically use your smartphone to play online games or to listen to online music or whatever. Yeah, I mean that's not the typical case. So that means most consumers are doing the same thing. Consumers are less heterogeneous in bandwidth, and that's why in that case you should price by quantity. Okay, so at least at least our analysis and insights we obtained can allow us to explain these parts. Oh, we build a model and then we solve the model. We get some explanations in theory. Okay, we care about moral hazard, we care about adverse selection, and then those theories at least partially allow us to answer these questions. Okay, that's good. We can somehow verify that our theory is not completely useless. Okay, so now at the end, extensions and conclusion. In the paper, they also did the following things. More general utility functions. The function need not to be projective anymore. As long as it's increasing and concave, separable, then the same result applies. Or in some applications, bandwidth, people are insensitive in bandwidth. In that case, certainly pricing by quantity is optimal. Also, it may be the case that when you want to serve more consumers, or when you want, let me start again. When you want to offer more high bandwidth consumptions, then there is a higher cost. In that case, you have an aggregate bandwidth cost according to what's the total aggregate bandwidth you serve consumers. Okay? Or another thing is about the disutility of waiting. If all those guys are using 3G networks, you know there's a congestion, and as a consumer, I hate congestion, right? So there may be some disutility if there are too many people using the same service. In the last two cases, we can show that pricing by minutes is still suboptimal. Anyway, it is always the worst in dealing with moral hazard and adverse selection. And also, pricing by bandwidth will become relatively more attractive. Why? Because now pricing by bandwidth allows you to control for congestion, allows you to take care of bandwidth costs. That's why pricing by bandwidth, when there is a supply side issue, may become more attractive. Conclusion? We compare the three pricing matrices. We can solve all of them, and in particular, they are pricing by minutes, bandwidth, or quantity. We can show that either pricing by bandwidth or pricing by quantity can be optimal, and pricing by minutes is just the worst, because in mitigating information asymmetry, it is just not so helpful. Yeah, because the remaining moral hazard problem is too strong. So, whether the seller should really price by bandwidth or by quantity now depends on how this pricing metric can mitigate or alleviate information asymmetry. So again and again, we emphasize on how critical information asymmetry is. Why? At least for the following case, I hope it is convincing. We always want to earn revenue at the consumer side, right? But the main difficulty is that we don't know how consumers like our product. This is a hidden information. Also, we don't know how consumers will use our product. In the product discussed in this paper is the data service, right? When you limit the consumer about minutes, they will use they will adjust the bandwidth and so on and so on. So we cannot control this, and we cannot see the valuation. They are just natural in any revenue maximization problem, in any pricing problem, in any marketing problem, right? So that's why you just cannot ignore information asymmetry. That's always an issue. So as we partly mentioned here, sometimes when consumers have the discretion to use products in a different ways, then after sales selection will also be important when we are doing something else. For example, when we are designing return contracts for consumers, return policies, or warranty policies, and many other consumer-related policies. Yeah, we're going to maybe do some discussions in the class, but anyway, take that in mind. After sales selections, more hazard problems. Okay, that's all. Thank you.